So, welcome to this presentation, which I've called Org Mode, Literate Programming in Emacs. And this is a re-recording of a talk I had the other week. And I would just start by saying that I'm using Emacs version 27, and I'm using a configuration called Doom, and it's available on GitHub. It's an Emacs configuration for the stubborn Martian Vimmer. So it has a lot of support for Evil and the usage of VI emulation in Emacs. So in case I mentioned any key bindings, some of them might be native Emacs key bindings, some of them could be VI, just so you know. And actually Org Mode was the thing that brought me to Emacs. And I started using it as my advanced note-taking program. So hopefully we will see why. But if you're not familiar with Emacs, I would start to say that Emacs has these different modes. And some of them are called major modes. So if you open a C++ file, for example, there will be this C++ mode which kicks in, provides you with syntax highlighting and auto completion, snippets, etc. And Org Mode then naturally is activated when you open org files. So org files are these special files, and I thought we could start by looking at the content of one of these files. So here I have the content of an org file, and in the right bottom corner you will see fundamental. That indicates that I'm in fundamental mode, and now I'm actually just seeing plain text here, because that's what an org file is. And we're using these asterisks to signal that this is a heading. We can include links to sites. We can have a list like this. We can have a numbered list. We can have tables, etc. And the fact that it's plain text makes it very easy to work with. It's easy to grep for content, or open it in another editor, or version control, for example. So so this is what it actually is. But now we'll activate org mode, and now everything got folded here. So here's the top heading. I press shift and it will expand. Press shift again and we'll close the content. So I can do it like this. I can move to the link. I can press enter and it will open up the link in my browser here. I can go back to this subheading. Here's a list. I press meta enter, and I can add an item. Add an item. I can open the next one. Meta enter again. Opens a new item and numbered item. Maybe I want to add another heading. I press Control Enter. This gives me a new heading. I can press Tab to denote the heading, so and Shift Tab to promote it. So here I have a table containing some text. So tab heading, demotes heading, shift tab heading, promotes heading, control enter. Yeah, what did I do? Create heading. I got too long again, but of course Emacs solves this for us. So just tab and it will correct the table for us. Meta enter adds another item to the list. Sweet. We can move to the top here. These guys, the Emacs and org mode here, that's tags. And tagging headings can be useful for finding or filtering content later. I can change this heading to to-do. And now I think I've gone through like the basics here. I mean, one thing to know is that org mode is massive. It's really this huge universe of possibilities. So these are just some of the rudimentary basics that you can do. But now, when I have this to-do heading, I can just press enter, and it will mark it as done. And I will get a timestamp to when I closed it. So this is nice. If we now look at the mode line, that's the bottom here, we can see the number 978, and then there is this symbol with two arrows pointing inwards, and that indicates that I've actually narrowed the content of this file called livepresentation.org. So we're not seeing the whole buffer here. I can use the command widen and close this one, and here's the presentation. So it was there all along, but I was hiding it, and that's another great feature because it makes it much easier to focus, you know. So yeah, let's go to the next one, which is literate-programming, and I will use this narrowing again. So narrow subtree, Control X and S. So here's literate-programming, and I will start by saying that there's a lot of great content out there, a lot of good videos to watch on YouTube, for example. So I'm really inspired by the work of Howard Abrams. I like the presentation on org mode by Harry Schwartz, Mike Szymanski's video series, or the Emacs Rock video series as well. It's just some of the interesting content out there. But I think it's always interesting to see other people's workflows and usage of this tool, because it's really massive. I mean, sometimes it's Emacs is mentioned as a text editor, and that's a huge understatement. I mean, it transcends what a text editor is. It's I think some are calling it almost like a Lisp machine, and these Lisp machines were popular computers back in the 80s, where they were completely hackable, so you could hack the operating system while it was running, and everything was built on Lisp. Now it's not fully that, but it's much closer to that for me than a text editor, and that takes some time to wrap your mind around, because I wasn't used to thinking about a tool like this. So it's more like this massive programming environment where everything is programmable. So hopefully you will find this find some new inspiration from this presentation. but if we focus on literate programming, this is for me the great thing is that you can mix code and regular text. So it makes it very easy to, like, if you do something for the first time, just document what commands you're using and what they're actually doing, or if you're digging into like some programming construct or an algorithm, you can have blocks of code and your notes associated to it. So org mode makes it possible to bring the context together. You can have the code and you can have the notes. Now, in org mode, literate programming is provided by an extension called Babel. So that's Babel. And we can create source code blocks. And then you just type less than s and tab, and it creates these begin src and end src. And here we could perhaps add a note. So show the content of my home directory. So if I want to do that in the terminal, I would cd to the home directory, and I will do ls. Now, this source code block, however, we can add actually specify the language. And if you look at the syntax highlighting, changed a bit. But that's not the only thing here. It actually makes this code block executable. So if I press enter, it would actually run these commands and take the output and put it in this result drawer here. So that's really awesome. I mean, I could run the command, automatically get it documented what it did, and of course it supports other languages as well. So let's look at this one, Elisp. So Emacs is built mostly in Emacs Lisp, and that's a Lisp dialect, and that's really one of the cool features of Emacs is that it's written in Elisp. So I can write some code, for example, format hello there, and it prints hello there for me. And of course we can run Python, and in Python you would print hello there, right? But the result is not. And that's because some languages by default it doesn't really there are some settings here that we can set, and the default one for Python is that results will show a value. So what we need to do is actually return a value. So this block should return something. So it will return a value, and now we get hello there. However, this is not really showing what print does in Python. So instead, we can undo this part right here, and I can change results to, instead of value, output, and then you get it correct. Let's take a look at another language like C++. Specifies a CPP. I will do include live stream, so we can course I need to type some more, and I find it more comfortable to write in something like there's a, we can press Ctrl C and single quote, and that brings the content up in this pop-up buffer. And here I will have the correct syntax highlighting, and I have that as well, but I could have access to formatting or snippets if I would like to use that, etc. So it's really useful. So I can yeah, you saw there, for example. Here I got some expected function body after function declarator. So it's linting the code for me. And then we'll add the cout. Hello there. So that's nice. Works as well. Of course, we can work with more advanced examples as well. We're not only restricted to something as easy as an hello there. Let's have a look at how that could work. So here I have the C++, and here I pass something, an argument called flags, and here I can specify like a path to the library eigen. I can specify the version that the compiler should use, so C++ 17, and I'm including some stuff here from eigen. I create a matrix and creating a vector and multiply the matrix and the vector, and I could just run this code and get some numbers. Not only have we support here for simple blocks, but we can make them quite advanced as well. Now I will widen the presentation again and go to the next entry with the chaining, because this is another important feature to know, and that is if we have this, for example, here we create a variable called my name and we echo the value. But let's say we are totally beginners here. We really want to document what happens in the different steps. So we need to split up the code. So we can do that. We can create a variable, and first we run that block, and then we have some more text and the next block. Unfortunately though, the output is empty, because this variable, my name, that's not set in this block, and these blocks are not connected in any way. So that's what's missing here. And then we have a construct called session, so that's a header argument. So if we give this block session and the session name, session shell chain, we can first execute this one and then move to the next block and execute that one, and it will work. And we can see in the background that we have this session shell chain. It's an easy thing to say. And so here's the running shell session. So it's running there in the background. So we can write new blocks and execute in the same sort of like environment. And we have support for other languages as well, which have these sort of like REPL-based, like Python, which has the IPython. So you can start Python and work interactively there. So let's have an example of that. So create this Python block. So here I have some Python code. It creates a function called calculate sum, and in the next block I want to use this. So I'm calling calculate sum over here. But I don't have a session command specified, so I will need to do that for each block. And instead of doing it for each block, I can do it up here. I can have a properties. And specify header args session. Using the same terminology here, so I can execute this command. There is some warning there that I haven't looked into. So that seemed to work. I can press enter on the next block, and it can actually call the calculate sum. So this is a really nice feature for languages which supports this session argument, or for shells. I mean, it comes naturally, but that's not true for all languages. So what other things do we have in our toolbox? Well, we can do some composing of blocks instead. Yeah, so there is a feature called KnowWeb. So we can take a look at the previous Python example, and that would be this. So here's the function again, and here's the other block. What has changed here is that I've given it a name. So this block has the name Python calc, and that makes it possible for us to reference that block in other blocks. Another key feature is to enable this KnowWeb for this block. And here is the syntax to reference another block. So less than Python calc, greater than. Yeah. And effectively what will happen here is that it will take the code from the other block and inline it behind the scenes in this block. So pressing enter here will execute nicely. Now another feature of this, which I personally find very cool, is that we can actually also mix languages with some restrictions. So we can do something like this. So we can mix Python and ELISP code. Now this block is very similar to the one above there. We're including Python calc, but when we're generating the numbers here, we're actually calling the ELISP code. Now, of course, ELISP code can't be inlined here because that will not run in Python. But when we add the parentheses to the name, we are not inlining the code, but inlining the result of the other block. So this block, for example, evaluates to 74, and therefore this one gives a much larger number, because here's the sum becomes much bigger than before, because we were using the for x in range 20 before, and now it's in 74. So that's a way to actually mix languages as well. I find it useful sometimes actually, and otherwise it can be done mainly for fun. So why not? Yeah, so what else do we have here? Note-taking. Well, obviously mixing code and notes works really great here, and this makes also, for me at least, org mode to be a super great tool for learning new things, especially if you're studying programming, for example, because then you might have some a book that you're following, and there might be things that you want to take notes on, and examples that you want to play around with yourself. I mean, you can learn a lot by like experimenting with examples and see what happens if you change something, right? So it makes it natural for that. And I can show you some notes that I've taken. So here's another cool thing in org mode. I have a link here, and that is a link that links me to another file. So when I press enter here, it brings me from livepresentation.org into a file called hackingnotebook.org, and it brought me into this if special form. And that because when I was here, I actually took org store link, and when I store a link and then later reference it, it will bring me back to an exact position as well. So it brings me back to this section, because this is where I took the link. So I could, for example, like reevaluate this block, have a look at these comments or whatever I want to do. Although one thing that I realized was that we're missing one piece of the puzzle here, because to really grasp the notes, I'm missing the context of where I took it. If I would have access to the page where I were, that adds extra context, which makes the notes and the code makes more sense. Now in org mode, there is a great package. So there is a package called orgnoter that you can install. And here orgnoter has added some metadata for me. So it added the path to the book, An Introduction to eLisp, which these notes comes from. And since I have that here as a property, I can just call orgnoter, and it opens up the PDF on the left hand side and my notes on the right hand side. So I can navigate through the document here, and it will go through my notes. It will expand and contract the notes on the right hand side as we move through them. I could go here and go somewhere else and say sync to this location, and it synchronizes the left hand side instead. And yeah, I can jump between the different headings and sync the left hand side. So that's a great tool for taking notes. So I will close it and just go back, and here I am in the presentation again. So it's easy to like navigate around. I mean, it just doesn't matter that the files are located in different paths. We can create links and link the information together. Now, linking to a specific file, that's informative, of course, but usually you're interested in a small section of a file. And that's where org capture can actually be used. So in Emacs, all functions are globally defined, and we can use something called find function. So I could jump to org user and maybe to the insert heading, and it takes me to where this is defined. And maybe I think that this part is interesting, the do times here. I want to create a note with regards to this part. So I can open up org capture and specify a code snippet. Now this is a template which I got from Howard Abrams, his excellent blog. So example of do times. So do times is a way to loop, if I'm not remember entirely wrongly, in Emacs. And I mean, that's also one great thing here. So we can, I'm not adding any text. Control C twice. The note is stored. But where is it stored? Well, it's actually stored in snippets.org, which I predefined it to be. Here's some other ones. So here's our example of do times. And I will have the name of the function where the snippet was taken from. I'll have the highlight that I did, and I will have a link to the actual source code. And if I press enter here, it brings me back to the starting line of my highlighting, and you can see that the line 536 is highlighted in dark, so that was the end of my highlight. Now another cool feature, of course, in Emacs is that we can just ask Emacs what this is. So help me with this one. Do times, that's a macro, so you loop a certain number of times. Okay, that's good to know. Back to the presentation. So with org capture makes it easy to also automatically create these links and extract snippets, etc. Let's expand that again. Now for the next thing, I was thinking of an example where we want to document something. So we want to know how to build our own Docker image. And the first thing we need to do is start the Docker service, because here I'm running Arch Linux and Docker. I haven't enabled it from startup. I mean, so I need to start it, and I need to have elevated rights to do it. So I will need to use the sudo command. And we can do that in source code blocks as well if we specify this sudo as this. Now if I execute the block, seem to do something. Let's verify. So if it works, I will have access to the Docker command. And I have. Now there are no Dockers running at the moment, but we'll get to that. So build an image. We would like to build an image, and should have Python 3. It will be a minimal Python 3 environment. And the first thing we need to do is specify something called requirements. So there should be some requirements that needs to be installed in this Docker image. Now having them here is great, of course, but we really need to specify an actual file on the computer, which we can use in the build step. So we could do manual work and copy the content of this block into an actual file, etc. Yeah, that's too manual. So we can use another header argument, which is called tangle. And with tangle, we can specify a path, Docker image, and then requirements.txt. The path we specify here will be relative to the org mode document. So I can open up dred, that's the directory editor in Emacs. So here we are. Now the thing is, we want to create it inside a folder called Docker image. Now to make that work, I added a header argument here, which is mcodrp, and that makes it so that it creates all the necessary directories that is needed to tangle this file. Now to tangle only this block, I first press Ctrl U and then tangle one code block from live presentation. Okay, open up dred, and here's the file. Alright, it worked. Close this one. Then we have the Docker file. That's the next thing we need. Okay, here's the step or the content of a Docker file. Now, I'm a bit unsure what everything does, so I will like to have an example of that. Here's my example. So this content up here, I decided to split it. So first I create some from and specify what that is, copy, run, and command. Now I can create this Docker file over here where I utilize the KnowWeb syntax that we saw before to reference these other blocks. And of course KnowWeb can be combined with tangle. So when I tangle this file, the result becomes this. So that's perfect. Then the application. It's a very simple application. So it's just a little Python for loop which prints the value of the loop variable. Yeah, so we'll obtain you as well. And now we just need to create image. So run the docker build command. It's successfully built. Now we can verify that we have a Docker image called minimal Python. Yeah, we do. I haven't changed it since I built it the first time, so I guess that's why it has the old timestamp here. And now let's execute the minimal Python. And as we saw up in the Docker file, it will when we start the Docker, it will run the command python followed by app.py. So it will run our app.py, and we run it, but we have an error. So the error is due to invalid syntax, and that's because our application was written with Python 2, and we explicitly said it was Python 3 environment, so that's why it doesn't work. Now, it would of course be easy for us to go back to the code block and make some changes, tangle again, rebuild and verify. But let's say we run into some problems that is bigger than this. Then this loop for just like trying something new becomes a little bit tedious if we need to do it a lot of times, right? So we want something else here. So improve debugging. Right. So the first thing I will do is that I will create a block which starts the image and keeps it running, because it's running in a session, so that will be alive. So I start that one. Didn't have any output. We can verify with Docker PS that it's actually running, and it seems to be doing that. We have minimal Python there, and it's called, it has the name currently Romantic Feistel. It's a strange one. Now we could actually, in Emacs there's something called TRAMP. That's transparent remote access multiple protocols. And that's a feature that makes it possible for us to, for example, edit remotes on edit files on a remote computer. And there is a package called Docker Tramp, and that makes it possible to actually edit files that is running or that exists in a running Docker image. So that sounds like something that's useful right now. So I can use find file, remove everything here. Then I use a syntax called Docker romantic Feistel, and then app.py, and here's the file. And yeah, we're actually open the file on remote. We could also do something like this. We can split in a window here and opening a shell, but it's not a regular shell, it's E shell. So you might have heard about Bash and C shell. I mean, C shell is really awesome. And Emacs has something called E shell. Performance wise, it might be lacking when it comes to like handling large amount of text output, etc. But the really cool thing is here that we have access to everything that Emacs has. So all the functions and everything are callable from the command line. So we could do something like this. We could cd and then say that we want to cd into Docker. And then we said it was, I forgot the name of it, romantic Python. And here it auto completes. So this one. And now I'm actually inside. There's my requirements. So I can do requirements. Yep. That's it. That's all great, but now we're focusing on org mode. So how can we make org mode sing with Docker as well? Well, we can actually specify dir and use tramp here as well. So we will say that Docker and take install ls. Yeah. So this block is running remotely in the Docker image. Now, one thing here though that is a bit problematic is that I needed to specify the nickname sort of the image, and when I will restart the or start the image later, you will get another nickname. So hard coding here might not be the smartest thing. So I want like a more general approach to it. So for that I wrote some elisp code. Which we have here, and that's two functions, the Docker match and Docker path. And over here I'm calling Docker path with the name of our image, which is minimal Python, and it will get me this tramp compliant Docker name. So I mean, the output really looks like what was inside these quotes here. And now we'll see another cool feature of org mode and of Emacs in general, and that's the usage of elisp. So we can make a block here which creates a session Docker agent and directory, and then we're actually calling elisp code inside these parentheses. Now this my Docker path, that's the kind of Docker path we saw above, but I've installed it on my Emacs in my configuration. So now I just need to run this command, and it just worked. And now I have a running session that other blocks can just connect to, you know. So let's solve the syntax problem. So wasn't it? Right, here it was. So so I can actually use this function again and provide the image and name and application and use it inside Tangle. So this is hopefully a solution, Tangle. And now we have tangled it into the running Docker image. So now we just want to create another session block which uses the session Docker agent and try out our solution. Now, when I originally held this talk, there was a great question at the end, which was if I would like to create a new block which uses the same session as a previous block. Can I do that? And that's something that I would like to show how that can actually be done. Because if we look here, you can see that it's not that simple, because right now where our cursor is, the previous block is a Python block and it doesn't have a session. So we don't want that block, but the block before that one is a shell block and it has the session that we're after. So we would like to use sort of like the same name as that block. So how can we do that? Again, the solution is to write some Lisp code. So here I have a function. What the function does is that it goes from where the cursor is, moves backwards in the buffer through only source code blocks. And once it finds a block that has the session argument, it will return that session name together with the language that it uses. So if I execute this block, you can see that it finds this previous block which was using shell and had a session Docker agent. Right, that's perfect, that's what I would like to have. But it would be really cool if we can actually use it in some kind of snippet way. Because when we create the block in general, we just write less than s and it expands to this block. Now I want a snippet solution as well for this. And the solution would be to write a snippet like this. So it will use the less than ss instead, and begin src and src. Right, but we need to provide something here, and most snippet languages uses some kind of templating, and yeah, I mean that can be powerful, but it's not as powerful as here in Emacs, because in Emacs we can get a snippet that actually embeds eLisp code. So here we can call my org previous session, and just by writing it like this, it will expand and create a block like we want. So less than ss. Of course I would need to install a snippet, and I've done that beforehand. Expands to this previous session. Now let's try if the solution worked. Python app.py moment of truth, and it worked. So now we know that our code is working in the Docker environment that it will run in later. So now we can safely tangle and build a new image. Now I have one more example, and I've done an example here where we want to do some performance analysis of an algorithm, and of course we don't have time to generate actual algorithm and get some real data. So I will just synthesize the data and synthesize the estimate as well. So I have this simple algorithm in mind. We just have a one-dimensional signal. We want to track the value. We say that we have some algorithm that does that, and now we want the true data, and we want the estimated data. So to do that, I'll create this source code block, which contains Emacs Lisp code. You can evaluate it, and I'll specify that the output results should be put in a table. So the first column here that contains the true value. The second one is the estimated. It's following, but it's a little bit off. But looking at the table here, I don't really. I mean, that's a lot of numbers, and if I go back later, I might like wonder, okay, but which data was what? So can I improve that in some way? Well, I can create this other block here. So that's also Emacs Lisp code. And I go to my previous one and add a post argument. And then I reference my new add header block and pass this. And the post command will run after the code block is evaluated, but before the results are actually printed. So it will take the output from this block and go back down here, and it will add a horizontal line and add the label truth and estimate and then a horizontal line, and then it will come back up here. So running it will show me this. Now it looks much better. I'll also add a name. So truth data. I'll add a caption as well. Truth and estimate. Truth and estimate. All right. Looking at the data this way, I mean, it makes sense. But I also find it very useful to visualize it, of course. So I don't know how to do that in Emacs Lisp, but I do know how to do that in Python. So I can use this block. And here I create a variable called data, which has the value of the table as the truth data. Now the results here will be a file. So if I run this, the output is a broken link. It becomes red. So I open dred, and I'm missing the folder I'm trying to write to. So images, execute it, and the image is transferred back into our buffer here, which is pretty cool. Yeah. Now, I can do something else as well. I could, for example, use Octave, and if I run that, I'll get another plot. So this would be Octave plot, and I'll name you So this is great. I mean, we can use the power of other languages to visualize what we want here. I ever tried to make some kind of table here with the data, and we saw earlier in the beginning of the presentation that tables are pretty awesome. At least it has this awesome feature of auto adjusting the boundaries, but it has also the possibility to have table formulas. So by pressing Ctrl C and a single quote, we bring up these field and range formulas pop up. And first one we see here, it takes the data from the remote table as the truth data and copies it over here. Same goes for estimate. Error, however, calculates the error, first column minus the second one. This syntax is called Emacs calc syntax, and this block, however, uses Emacs Lisp code. So here we're calling the abs function, the elisp abs function, and the minus function. So that gives us the absolute error. This one uses again some elisp code to calculate the length of a list here, so it gives us the number of values. Then I want to calculate the mean error, and for some reason I'm referring to something called mean. So what's that? Well, that would be this block. So here I have an elisp code block, and I call it mean, and it does some calculations which calculates a mean value and returns it. So here we can actually call another block and make that block perform the calculations for us. Now I also calculate the RMSE, the root mean square error, and to calculate that one I use Python code. This is a block with Python code and using NumPy. And if I go back to the table formula, I can press Ctrl C twice, and it actually performs all the calculations and gets this mean error and RMSE and everything, which is seriously cool. So it's yeah, you can really do a lot of things with these tables. I had actually no idea that they were that powerful. Now I would like to describe the flow that we have had here in our investigation so far. So for that I will be using PlantUML, and I can actually evaluate this block of PlantUML code and we'll get this image back. So it describes how we firstly synthesize the data with Emacs Lisp and then improve the results with the post command. We use Python to visualize the data. We process the data through our table formulas, which uses elisp, the Emacs calc and code blocks. And we visualize the flow with PlantUML. So that's really nice. Realistic caption. Cool. Now, I mentioned that there was something called Emacs calc. And at first I just thought that, that's something simple like the Windows calculator or something. Of course I was wrong. Turned out to be much more powerful. So let's look here. So we can do some. Not only can we use it in formulas in our tables, but we can also use source code blocks, of course. So calc. We can do 10 plus 3 times 5 divided by 2. Simple. Maybe cos 180 degrees, that's -1. So for some reason the default seems to be degrees instead of radians. Probably some setting somewhere. But what about an equation? X times 2 plus 4. No, plus x equals 4. Yeah, it simplified actually the equation there. But what we actually can do is to solve it. So we can call fsolve with respect to x, and we get the value of x. We could also take an equation like the square root of x and then derive this with regards to x. And it makes a derivation. And this is what I found fascinating with org mode. It's like how easy it is to like, well, but what if this is true? So can I do this? And then usually you can. Or if you can't, you can write some Emacs Lisp code that makes it possible. So my thought when I saw this was that, okay, but if that is actually possible, then I should be able to create a table. That's not a table. So a table looking like this, and I should be able to derive it to calculate the derivatives. So I could say that the second column should be the derivative of the first column with respect to x. And it just makes it sing. So give this in the caption as well. Also calc. I think I saw some comments somewhere that the Emacs calc is really a poor man's Mathematica. Probably that's a more accurate description rather than that it's the Emacs equivalent to Windows calculator. But now we've done a lot of things here, and it would be really nice if we could share the results, with others. And unfortunately, we live in a world where not everybody has org mode. So we will need some kind of other document to share, right? I mean, we could use Markdown. It's easy to export org to Markdown, but again, that's a little bit limited. So we'll opt for PDF instead. And PDF, that's nice, but this is a bit technical, so ideally it would be using LaTeX PDF. Right, so that's what I want. And so I will use org export PDF LaTeX. here we have some command called org latex export to PDF or org pandoc export to latex PDF. Right. I'll use that one. And a PDF was produced. You can watch it here. Yeah, here it is. However, there is something that bothered me when I was looking through those commands, because it was org latex export to PDF. There was a pandoc version as well, and there was a pandoc version that had and open, and that's really what I want. I mean, I want to create a PDF and have it automatically opened, or at least have the option to it. So let's improve that. So improve export, and I don't want to export this one, so I will do another example. So here I've written some Emacs Lisp code. It's a function called org latex export to PDF and open, which is what I want. And it figures out the file name and calls the org latex export PDF, and then opens the output file. So all I need to do to be able to use this in my Emacs now is to evaluate this function. And now it becomes a part of this running Lisp machine that we have here. So org export latex PDF and open. It's here. So I run it. And I get the output. So here we have the performance analysis. We have the code that we use to generate the data. It has syntax highlighting. It's more code with syntax highlighting. There's our table. There's our tracking performance. There's another plot. Our flow. Here's some examples of calc, and our table over there. Yeah, of course you can do some tweaking of these things to get the results a little bit cleaner. If you want like LaTeX equations, we can just write them in plain text here in org mode, and when we export them, they will be correctly formatted in the PDF. So we'll come to summary. Yeah, and for the summary, I think it's a good opportunity to show that we can go beyond org as well for our presentation. So I'll narrow to this one, and I'll do org reveal browse. So org reveal export to HTML and browse will take that part of my document and create a HTML presentation. So here's the summary of what we have seen: org mode and literate programming. I think one of the things here that we've seen is context. So org mode and Emacs makes it easy to bring everything into context. You can have the notes together with your PDF files, together with the code. You can have links that makes it easy to just transition to other files that actually are not located nearby on the computer, but in a logical sense. And it also makes documentation easy, because documenting the steps that you take, for example, when we made the Docker image, we don't need to add that much extra work in order to actually have something that makes our results repeatable. At least for ourselves. Maybe we'll add some more notes if we would like to describe it for others. But that's easy to do. I mean, it's just text. And another great feature here that we've seen is that org mode is part of Emacs. And Emacs is really this tool which is not only something that works for you, but rather how can you make it work for you. So if there's something that we don't like or some feature that we are lacking, we can just easily extend it. We write some more Emacs Lisp code, and that's just super easy to install into a running session even. And then of course exporting features. So this really makes it easy for you as a user to kind of like not need to use as many applications. We can remove some of that these limitations. So and there comes a great benefit of tying things together because of the context, so we can just export it to Markdown or PDF or HTML, etc. Super useful. Yeah. So that was all for me. Thanks for listening. I only got one more thing to show you though. So let's go back to the presentation here. There was something at the end, so here's the picture, that I didn't show, and that's blogging. So let's turn something of what we have made into an actual blog post. So I will go through this link into my Emacs-based blog, and what I will do is start a server here, and then I will open Firefox and navigate to localhost. And here's actually the content of the org mode file. So here's the org mode file. Here's a statically generated website. So let's look at how we can actually create a new blog post. So I would like to generate a new entry which will show how to automatically open PDF on export. And that's Emacs. I tag it with Emacs, I tag it with org mode, and keylist. Like this. And what we need to do as well is add some properties. And export file name. So name open PDF on export. That should be unique. Oh wow, did you see that? I saved and it popped up here. So here it is. It got the, the tags, the Emacs, org mode, and eLisp. Nice. I will do enter some text. Save. Pops up there. And then the code that I wrote. And now it's exported here, and we got a code block with some syntax highlighting, showcasing the code that was written. So that's nice. And actually, all I need to do, first I need to mark this one as to do, and then I need to just mark it as done, and then it will be treated as not as a draft, which it would be if it had the to-do item, but when it's done, it will get this timestamp and it will get yeah, it will be considered an actual post. However, it's not on the actual site yet, because I'm running this local host here. So I will skip this down and go back here. I will post about automatic PDF, and then push it. So here I was using Magit, which is another great feature of Emacs. It's super easy to work with Git repositories. Now if I look here, I have a shell script called deploy. If this works, I should be able to, let's see. I would have expected it to show up. It takes some time still. And there it is. Here's the blog post. Automatically open PDF on export. Perfect. Close this one down. Navigate back to my presentation. And that's it. Thanks for watching.